and we'll go ahead and get started. So today we're looking at equations involving radicals, and you know you have a radical equation when there's a variable under the radical, or the variable has a rational exponent. Do you guys remember that rational basically means like a fraction? Fractional is how I like to look at it. So let's dive into what that means just a little bit more before we start. If I look at the square root of x, that's a radical. Why do radical equations also include fractional exponents? Can someone raise their hand and tell me, how would I write the square root of x as x raised to a fraction exponent? How would I write the square root of x as x raised to a fraction exponent? Ah, you all know it. X to the 1/2, I think I heard. Because really, if there's nothing in the radical, 2 is understood to be there. So this would be x to the 1/2. So today we're going to be looking at radicals and fractional exponents because they're actually the same thing. Another thing to keep in mind, we learned this way back in chapter P, and it's going to be important for today. If you're given the square root, for example, if I ask you what is the square root of 4? 2. 2 is the correct answer. Notice you didn't say -2. That's because this radical is understood to be the principal root. And the principal root is always asking for the positive solution. Since the principal root has positive solutions, and when you're undoing it, sometimes there's pluses and minuses involved, you always have to check your solution. It is quite possible in a radical equation that you could have an extraneous answer. We've seen these before. Do you guys remember what these are? Extraneous solutions? No, it's been a while. Extraneous solutions are solutions that you get in your work, but when you plug them back in, they're not actual solutions. They don't make the equation true. So go ahead and write extraneous solutions. Those are solutions that you get, but don't make the equation true. They don't work, so you have to throw them away. All right, also guys, after this lesson, I'm gonna give you time to work on homework. If you have any distractions right now, if you could put those away, the more you dive in, the easier it will be to absorb, and then hopefully you can even get a good amount of homework done in this block day as well. Okay, so how do we solve radical equations? Here's the steps on the side. We'll just walk through them. Number 1, isolate the radical. So get it by itself. How would we do that in example 1?
Oh, no, add.
Good, add the 2. And that gives me the square root of 6 minus 3x. We will be squaring something, but we're not actually going to manipulate the number to make it factorable, so it's not quite completing the square. But now we could look at step number 2. It'll say square both sides, but you guys hopefully know why. What undoes a square root? Square. So we'll square both sides, good, and the 2 squared will become 4. The square cancels out the square root, and we're left with 6 minus 3x is equal to 4. Now this is a linear equation, meaning it's not quadratic. We just need to get x by itself. So we'll subtract 6 to each side, giving me -3x is equal to -2. Divide both sides by -3. What's a negative divided by a negative? Positive, so the answer would be positive 2/3. But what do I have to do before I box it? Check it. Do we know where to check? The original equation for x. Just don't plug it into anything that's really not in black print, because it's really the original equation that will show you if it works out. So I'm going to check, is the square root of 6 minus 3 times the value of x minus 2, does it really equal 0? So I'll plug 2/3 in. And we could plug this in our calculator. It might be easier to do it by hand, because if you look at 3, yep, it's 3/1. What cancels there? The 3. So this is actually just 6 minus 2. What's 6 minus 2? 4. What's the square root of 4? 2. Is 2 minus 2 0? Yeah, so this one worked out, and we know that x does equal 2/3. Okay, on to example 2. Example 2, step 1, isolate the radical.
We have a question.
Yeah. Yeah.
How did it go from 6 minus 2?
What is 6 minus 2? 4. And then what's the square root of 4?
Oh, we keep that.
Yeah, you got to keep it because it's still part of the original equation.
Okay.
So looking at example 2, the radical is already by itself. So what undoes a square root?
Mrs. Prentice, I have a question.
Yeah.
Is this 1.6?
B, 1.6 part 2.
Okay, thank you.
And then we square both sides, and the square cancels out the square root, and we're left with x plus 2 is equal to x squared. Now you have to,
Squaring both sides first
because you need to get rid of that radical.
because there are you.
Yes, it was already by itself. Yeah, it's not a number. And in fact, this brings about a different situation. This is not a linear equation. This one is a quadratic. So yes, we have to think about what are our options. Because there's another x value, we can't take the square root. So the other options consist of factoring, quadratic formula, or what's the other option? Completing the square. What would you guys do first here? Subtract the x, subtract the 2, set it equal to 0. So I'll subtract x, subtract 2, and x minus x is 0, 2 minus 2 is 0, and I have 0 is equal to x squared minus x minus 2. Now, if you've set it equal to 0, your two options would be factor or quadratic formula. What would you guys want to do here? Factor? Yeah, factors nicely here. If we break this down, the last term is negative, so we know we're going to have different signs. X times x would give us x squared because we had to subtract it to the other side. Because
Wait, it wouldn't be like.
you might have forgotten to subtract it. Oh, you could do that, but then if you're going to factor, you need to get rid of that negative. So you would divide everything by -1, and then you'd be right to where we are.
Okay, so just whatever x squared, what side that's
Keep-
on, just to move it on that
Yes,
side.
actually, Haley, you're bringing up a really good point. Guys, if you're using the factoring methods that we've learned, you want to make sure that x squared has a coefficient of a positive number, because that's really what the trial and error works with. So thank you for reminding us of that. Okay, so now factors of 2 would be -2 and 1. Where do you go from here? Good, set them equal to 0 and solve. So we get x minus 2 equals 0, add 2, giving us x is equal to 2. Set x plus 1 equal to 0, subtract 1, and we get x is equal to -1. What do I need to do before I box it? Check it. Awesome. So I'm going to check it back into the original expression. I'll check x equals -1 first. So I'm going to ask, is the square root of -1 plus 2 really equal to -1? Because I'm plugging this in for x. -1 plus 2 is 1. Is the square root of 1 equal to -1? Careful, go back to the top. If the square root is given to you, it's asking for the principal root, which is always asking for the positive answer. So
What do you mean?
if it's in black print on paper, it's understood to be the principal root. And so you're always looking for the positive solution.
How do you?
If you yourself draw in a square root to help you solve in an equation, you have to take into account.
So whatever, like, is given.
Yes, yes. So this is given to us. In fact, I could even,
So you can't, so you're not looking for the principal root,
on number 3,
assuming if like if you were to use it.
if you had to, basically, if you're undoing a square, then you are drawing in a square root. So you're not thinking about the principal root. You're taking plus or minus. But this one is given to you. So it's basically asking for what's the positive square root of 1? Is it -1? No. So we would say this actually doesn't work. It's extraneous.
Do we have to write?
You don't have to write extraneous, but you do have to throw it away. So, I mean, you could say it's extraneous, but on like a multiple choice situation, it just wouldn't be there. Caroline. 2 might work. Let's check it. If I check that in and I ask, is the square root of 2 plus 2 equal to the value of x, which is 2? We'll plug in 2 in for x. The square root of 4, does that equal 2?
Yeah.
Yes, and so x equals 2 is our solution.
So if it's equal to 0, it can be a negative, like the x can be negative also.
If it's equal to the value of x,
Oh,
then yes, if you're given a principal root, that x value can't be negative. Good question. All right, guys, next one. What should be our first step? Good, subtract the 1. Subtract 1, subtract 1. And I have the square root of 2x plus 1 is equal to x minus 1. What undoes a square root? Square, good. Now here is something very important you want to be careful about. First of all, the square undoes the square root. So I have 2x plus 1 is equal to, but now x minus 1 squared. I've seen this on the SAT. I was looking at a practice SAT the other day to see kind of what skills are focused on. And this was in the context of a problem. So if a student got it wrong, they would definitely get the answer wrong.
So you have to.
Yes. Caroline, if we FOIL it, saw your hand up, what would we get? Oh, did you have that? Or did you just know to FOIL? You knew to FOIL. Awesome. So if we FOIL this, first times first would give us x squared. Outside would give us -1x. Inside would give us -1x. And last would give us a +1. If you forgot to FOIL that, or that just wasn't on your radar, make sure you just put a big like highlighting thing, because this will show up in the homework as well. Make sure to FOIL if you have 2 terms. So now we have 2x plus 1 is equal to x squared minus 2x plus 1. What type of equation do we have right now? Is it linear or is it quadratic? Quadratic. How do we know it's quadratic? Because you have a 2, a power of 2. So what should we do to solve a quadratic? Factor. What do you have to do to factor? Set it equal to 0. So let's subtract 2x, subtract 2x, subtract 1, subtract 1. And we'll get 0 is equal to x squared minus 4x. What's 1 plus -1? 0. So if you were going to use the quadratic formula, you would want to make sure that you notice that the constant is 0. You actually don't have to use the quadratic formula here. You could. There's actually something even easier. Caroline? There's a GCF here. Class, do you see it? What is the GCF? X. So if we take out the x, then we would be left with x minus 4. And then what'd you say? You would be able to square root if you didn't have this x here. But sadly, if we tried to take the square root, we would add 4x to the other side, and then we couldn't take the square root of that x. But that's a good point. If the x wasn't there, we could square root. Then we would set each of these equal to 0. We would get x is equal to 4 potentially, set x equal to 0, or potentially x equals 0. Okay, turn to your partner, the youngest person in your family. So if you're the youngest, then you do this problem. If you're both the youngest or the youngest in line, then whoever's youngest in age, actually do the check step. See which of these check out. Mario, are you the youngest in your family?
Yes, I am the youngest.
Olivia, you're the youngest too, right?
Yeah.
So out of you two, which one's actually younger? Mario, when's your birthday?
September 14th, 2004.
What's your birthday, Olivia?
August 12th, 2004.
Ah, so then Mario, you're the youngest.
I am the youngest. So what we would do next is we would check by doing a square root and replacing the x with either 0 or 4. So in this case, we could start with 0. So we
Okay.
do
2
What?
times plus
Oh, yeah.
1 plus 1, you're asking, does it equal 0? So we would have the square root of 1 plus 1. Does that one work out, girls?
you would have the square root of 0 plus 1 plus 1. So it would just be 2.
Right. So does 2 equal 0?
And
No.
it would just be the square root of 2.
It would be just 2. Yeah, so 2 doesn't equal 0 because when we plug x back in for x there, it doesn't work. So we would say x can't equal 0. And then if we plug in 4, we would ask, is the square root of 2 times the value of x plus 1 equal the value of x? So now we're checking, does x actually equal 4?
Oh, I didn't plug in.
And 8 plus 1 is 9.
Sorry if I'm not responding. My internet's kind of like unstable here, so the words are a little bit glitching right now. Sorry.
That's okay. So then we get 3 plus 1 gives us 4, which I think does work.
Mhm.
So that should work. All right, guys, how did we do? Did we get x is equal to 4 is actually the only one that works here? Yeah? All right, next page. Now that we've practiced working with radical equations, let's use those techniques to solve the following. Consider this. The square root of x equals 4 is the exact same thing as x to the 1/2 equals 4. So I can actually use the exact same method to solve. What, again, undoes the square root? Square. So I could square this side and square this side, which means this equation I could do the same thing because it's the same equation. Now, if I look at these numbers, 1/2 and 2, there's actually a unique thing about those numbers. In fact, I'll go ahead and write it out. 1/2 and 2, or I could just say 1/2 and 2 over 1 are something, there's a math word that we could use to describe them. Starts with an R. Reciprocals. 1/2 and 2 over 1 are reciprocals. And that actually is the key component to being able to solve if you have a fractional exponent. To get rid of the fractional exponent, you're going to raise it to the reciprocal power. If you're looking at how does that work out mathematically, when you raise an exponent to an exponent, you multiply, it would cancel. 1/2 times 2 would give me 1. And I would have x to the first power equals 16.
But you would still have to like raise it.
You'd have to raise the other side to the reciprocal power as well. Yeah. So the goal when solving an equation involving a rational exponent is to raise both sides of the equation to the reciprocal power. So go ahead and write that in there. It's to raise both sides of the equation to the reciprocal power. Okay, the other important thing to make note of is since a fractional exponent is really just a radical, you still need to isolate that piece before you go about solving. Sophie, yeah. So if you look at number 1 doesn't say isolate the radical, it says isolate the exponent. It really means isolate the exponential piece. So really, when you're looking at what is the exponential, you have to isolate the base raised to the exponent. So let's talk through what that would look like for example 1. Example 1, I need to isolate that fractional piece or that radical in disguise. So right now it's being multiplied by 3. What undoes multiplication? Division. So we would divide by 3, and we would have x plus 3. Those pieces would cancel. So x plus 3 to the 3/4 is equal to 27. Now, based on what you did above, how would you get rid of this power 3/4? You could put it into a radical, but it might be more confusing of how to solve it. Multiply by 4/3. And when we say multiply, we're meaning raise it to, right? Because I had to get rid of this 3 here. Because you have to isolate this guy first. Because that's really a radical in disguise. So we have to isolate that radical. And to do that, you want to divide both sides by 3. It would be similar to something like this. If you have 3 times the 4th root of x plus 3 cubed equals 81, you need to isolate that radical. So what undoes multiplication? Because right now you have 3 times this. So what undoes divided? So that's what we just did. We took and we divided this by 3.
I just don't understand what happened.
Oh, I'm not done. So now I still have x plus 3 to the 3/4, but I'm going to raise it to the reciprocal power. Now, yes. So when you raise an exponent to its reciprocal, it becomes 1. So we just have x plus 3 is equal to 27 to the 4/3.
Do we always have to bring,
Raise it to the reciprocal.
no, for like the next one?
We'll get there. Let me go to the steps. We'll get there. Guys, this brings us to really step 3. You do need to remember this piece from the prerequisite chapter to be able to solve these. A to the m over n power is equal to, well, do you guys remember? Is n or m the index of the radical? N, good. So it'd be nth root of a. And if you're doing it by hand, it's easier to take that value and raise it to the mth power. Or if you were simplifying a radical, it would be easier to look at it in this way. So let's talk about what we should do now that we're kind of at the 3rd step. 27 to the 4/3 power. Let's convert that using that rule. Which one's going to be the index, 3 or 4? 3. So we're looking at the cubed root of 27.
That's what I thought. We could do that.
Not with 81 because we had to divide by 3 first. So we're going to have to take the cubed root of 27 and raise it to the 4th power. Anybody know what the cubed root of 27 is? Yep, because 27 is 3 times 3 times 3. So the cubed root of that is 3. And we're going to take 3 and raise it to the 4th power. And this is equal to x plus 3. What is 3 to the 4th power? 81, good. And then what do I do to finish this? Subtract 3. And I would get x is equal to 78. But what should I do before I box it? Plug it in and check it. And you can do this on your calculator. You do want to make sure that you plug it into the original equation. So I'm going to see, does x equal 78? And to check that, I'm going to ask, is 3 times the value of x plus 3 raised to the 3/4 really equal 81? So I'll put 78 in for x and see, does it work out? Probably, because we'd have to take the 4th root of 81 and then cube it. So let's see, do we know how to enter this in? We would type 3 times parentheses 78 plus 3. And then do we know how to raise it to a fraction? Alpha, and you could go to y equals and do numerator over denominator, or if your calculator works, you could just type in the button to the right of it, and it would allow you to put in that fraction, 3/4.
How do you like be able to?
And does it work? Yeah, so we box it, and we have got our solution. Okay, last thing we need to do is remember something before we can solve example 4. Remember when solving, if you have x squared equals 4, how do you solve this? What do you do? Square root. What do you need to keep in mind when you yourself draw in a square root in an equation? Plus or minus. Now, because this is the exact same thing as x to the square equals 4, and I could raise it to the reciprocal. What's the reciprocal of 2 over 1? 1 over 2. So if you have a fractional exponent with an even denominator, you're going to have 2 solutions. So let's write it. When you have a fraction exponent that has an even denominator, you need the plus or minus, well, I should say plus and minus answer. Because we know the square root of 4 is both 2 and negative 2. Okay, so that is going to be important for this next question. Let's go ahead and finish this together. Oh yeah, I'm sorry. When the fraction exponent has even denominator, you need a plus or minus. Like example 4. Because if I'm looking at example 4, what do I need to do first? Be careful. Those are terms. Those are terms. How do I get rid of this fractional exponent? Raise it to the reciprocal. So we're going to raise to the 3/2 power and raise this side to the 3/2 power. Those cancel, and I have x minus 2 is equal to, which one's going to be the index, 2 or 3? 2. So I'm going to take the square root of 9 and then cube it. What do I have to keep in mind when taking the square root in an equation? Plus or minus. Actually, no, you're going to get, because it's an odd exponent, you have 2 answers, exactly right. Because a positive number cubed will create a positive, and a negative number cubed will create a negative. So now we have these 2 solutions. We want to make sure that, or 2 equations, we want to make sure that we solve for both. So we have x minus 2 could equal positive 3 cubed.
Why did you switch it to
Because I took the square root of 9 in an equation, and so I need plus or minus, or you could see that the denominator of the fractional exponent is even. So it matches this case.
Why does it have to that?
I did. I raised both sides to the reciprocal power. So what gets rid of the 2/3? 3 over 2, but I have to do it to both sides. So now I have 9 to the 3/2 also.
I just don't understand like why you have
Reciprocal,
no like
plus or minus.
Yeah.
If you look at it like this, x squared equals 9, how would you solve this? Square root. Could I also say take this to the 1/2? Would that be the same thing? What do you have to keep in mind when taking the square root?
Yeah, that's fine.
Plus or minus. So what do you have to keep in mind when having an even denominator? Plus or minus. Because the square root of 9 is the same as 9 to the 1/2. So it's actually the same thing as taking the square root, which is why we need that plus or minus.
So just imagine basically.
Right. Yeah.
I think it's just the fact that I can see through.
Yeah, and it is brand new, but like that's why if we convert it from here to here, sometimes it's easier to see that we need that plus or minus.
Also, why are you keeping the 3 like equals to-
Oh, I'm not done.
Would it just be plus or minus?
What is the square root of 9?
No, not there.
No. Here?
No,
No.
below the square root. Yeah.
Here?
Yeah.
So I need to now evaluate what is positive 3 cubed and what is negative 3 cubed. And what is positive 3 cubed? 3, 27, good. And then we would add 2, and we get x is equal to 29. And then here, what is negative 3 cubed? Negative 27, and then I add 2. What's negative 27 plus 2? Negative 25. What should I do before I actually box it? Check it. Has anyone checked them? They should both work out. So if you check it out, you should get 29 minus 2 raised to the 2/3 does equal 9. Check. And negative 25 minus 2 raised to the 2/3 does equal 9.
Do you want us to use our calculator? Just
Yep.
for the sake-
That works.
easier?
Yep, for checking. Okay, if you guys could go ahead, you can take about 15, maybe 20 minutes to work on tonight's